In this video, we'll be learning about scatter plots, association, and correlation. Let's say we survey 8 women who are tracking the number of miles they walk. We ask them their average number of miles walked per day and their weight, and find that the first woman walks an average of 1.5 miles and her weight is 83 kilograms. The second woman walks an average of 1 mile and weighs 88 kilograms. The next woman walks 3.5 miles and weighs 73 kilograms. The next one walks 4 miles and has a weight of 75 kilograms. 6 miles, 60 kilograms. 5 miles, 64 kilograms. 4 miles, 70 kilograms. And our final person walks 4.5 miles and weighs 68 kilograms. One extremely useful tool when trying to see if there is an association or relationship between two sets of quantitative data is a scatter plot. Our first step is to determine which variable is the explanatory variable and which is the response variable. In other words, which variable could possibly explain why the other variable responds in the way that it does. In this case, if we want to know if the number of miles walked per day affects the woman's weights in our study, the number of miles walked could possibly explain the woman's weight, making the miles per day the explanatory variable and the weight the response variable. The explanatory variable, sometimes known as the independent variable, should always be placed on the x-axis of our scatter plot, while the response variable, also known as the dependent variable, should always be placed on the y-axis. We draw our x-axis using a uniformed scale, going up to the highest number recorded, 6. Then we do the same for the y-axis. Counted by tens, we go up to 90. Our first point is 1.5 on the x-axis and 83 on the y-axis. Then 1, 88. Then 3.5, 73. Followed by 4, 75, 6, 60, 5, 64, 4, 70, and finally 4.5, 68. Notice that the points cluster somewhat in the shape of a line. This means that the number of miles walked per day is in some way associated with the weight of women. It is important to note though that though we may identify a correlation in our graph, correlation doesn't necessarily mean causation. In this example it might, since higher mileage does lead to more calories burned. But suppose instead our variables were number of dogs seen on the street versus weight. There might be an association between the variables, since the women were likely to see more dogs if they walked for longer, but certainly seeing more dogs on the street does not cause a person to be lighter or heavier. It is important when analyzing correlation that we don't fall into the trap of assuming that correlation is the same as causation. Let's look more closely at the types of correlation we will come across. If our points take the shape of a line and have a negative slope, as x increases, y decreases, we say that there is a negative linear correlation. If our points take the shape of a line and have a positive slope, as x increases, y also increases, we say that there is a positive linear correlation. If we cannot identify a trend from our points, we say that there is no correlation. We can get more specific by also discussing the strength of the correlation. There is a strong correlation if the points are clustered close to the shape of the line, a moderate correlation if the points are a bit more spread out, and a weak correlation if we can identify the shape of the line, but the points are not clustered closely to it. We can use the words strong, moderate, and weak correlation to describe both negative linear correlation and positive linear correlation. Here's a summary of what we've learned. Scatter plots can be used to see if two quantitative variables are related. The explanatory variable goes on the x-axis. The response variable goes on the y-axis. Correlation can be categorized as positive, negative, or no correlation. Correlation can also be categorized as strong, moderate, or weak.